recording. Testing. Test. Good afternoon, students. Thank you, Pacey. Okay. Okay. We again because we just changed some of the lecturer didn't have this Google Meet recording, so we have to change to use some software to try it. I already upload the recording for last Thursday to the Google class, and if you find any problem, let me know. Okay. So next thing is the attendance okay? If you find any problem, let me know. I just remember today to update this. So normally during a weekend or early morning of a Monday, I will do the update for previous week. Okay, so if you until now you still haven't checked your attendance and try to check if you did attend but I didn't mark you attend, then try to let me know. Okay. So last week we stopped here, mentioned about the why this file database is not good compared to the actual DBNS. Okay, so we already mentioned if even one file can be used encryption to encrypt it, then anyone who want to use this file may need to decrypt first. They are only able to use the file, let's say Access or Excel. Okay, so this one is a way. Compared to the DBNS of this security, of course, it only regarding the open file and access it. But to control of who is authorized to access, who is authorized to do the changes. Okay, this part it may not have the ability to do so using one file. Okay, so this is why we have this DBNS for the security part. Okay, then I'll continue. The integrity part of this, of course, is the avoid incorrect or inconsistency. So during our last practical, we already tried this part. See, some of during your database development, we have this DDL define the database. So when we want to build the table, we need to mention, okay, so this field cannot must be primary key, and it cannot be null. Then some other key may state that this one is for date part. So the info or the data that key into this field must be in date format. Okay, so this one is the initial part of this integrity. Okay, so we have some example here. So property number varchar is not null, and below here we have this primary key property number. So you can see we have this primary key. Of course, we need to set it not null as well. Okay, so this one is for the integrity checking. Okay, then now for the inconsistency, let's say we have this by staff number having count greater than, no, sorry, not this part. Okay, I think gone. Okay, I think I better use this one. Okay, so for the integrity part, we have this checking for constraint. The supplier ID must be between 100 and 9,999. So this one is checking the supplier ID. The integrity, we already create this supplier in our database. So when you key in this supplier ID, the number must be between this number 100 to 9,999. So this one is the integrity checking. So this is some type of this integrity checking or constraint in Oracle. Of course, first one, the most important part here we have this not now. A lot of the time when we have this, let's say practical, if you send your car to do repairing or maintenance, so the fields of this part, when you register inside your car, so of course the car number. So the car number must, most of the time we use it as a primary key. Okay, most of the time we use it as a primary key, and it must not be now, yeah. Okay, so some of the field, when we want to use it as a primary key, it must not be now. Okay, some others, let's say unique. Let's say for our IC, when we are registered in, let's say JPN, this one is, let's say Malaysia, the Jambatan Pendapatan Negara. This one is a unique. When we register, when we born, actually they give us an IC number. So this must be unique. So anyone who born in Malaysia wouldn't get same ID as others. So this one is unique. So each of these table field, it may do some setting. So some of this cannot be repeat. Okay, so this one is the unique part. Of course, continue for the primary key. This one already mentioned. Some of the foreign key. One, the key in this part is belongs to or exists in another table, which is a primary key. Okay. Some of the checking here, we have the number, supplier ID fall between this number, then checking whether the name exists in the table or not. We have this IBM, Microsoft, and NVIDIA. So only this can be key in to the database. Okay, so this one do the checking. So it prevents some others data key into database. So let's say during this web page development, we have some restrictions during a development. If you want to choose the state in Malaysia, normally you only can choose 13 states plus some of the wilayah. Okay, so this one is already fixed there. So you only can choose based on this field. You cannot simply type Singapore or Thailand or whatever other country or other state in other country. Okay, so this one is some restriction. Checking whether it's not in this ABC. So this one is other way, another way of putting this not in this field. Okay, so this one is some of the integrity checking to prove to maintain the integrity of this database. Okay, so this is some DDL that we can try when we create a table and we want to create this table order detail. So some of this part we have this integrity checking. Of course, the quantity, when order something, the quantity must be greater or equal to 0. So if the quantity is 0, then no point we place this order. Okay, so the quantity must be greater than or equal to 0. If we go to let's say Lazada or Shopee, if when we do some let's say product add to cart, you want to buy something, the quantity must be there, otherwise it won't allow you to add to cart. Okay, so this one is another restriction as well. So of course that one is using web page control, but for the database we also can do such kind of a control as well. For price charges, the price must be greater or greater than 0. Sometimes it can be free. So this part it may be it may be a little bit based on a different situation. Okay, so let's say for I think Shopee, if you want to order some let's say SIM card, let's say yes. Previously they free a lot of this SIM card, even a 5G SIM card. You can just order. Of course, the shipping charges is charged, but the price charges for that particular product is actually free. Okay, so of course the website or the database and DBA may need to do some changes to allow this price to be set to free. Okay, constraint of other part here, we have this order to order detail. We have this unique items here. We have two items here, order key, and combine of this order key and product key. We want to set it for the order detail here. It should be unique. Okay, so for the record that key in, you cannot key in both of these to be the same in this table. Okay, so this one is another constraint as well. It is quite common that some of the table will have this combined unique key to prevent that. Okay, to prevent that this duplicate data. But of course, during this order, one order may have a lot of products. So we need to do some changes to this part. So combine of these two, then we can say that, okay, this order we have a different product, then this one is acceptable. Okay, so this one is okay. Okay, so this one foreign key, this customer order key is reference to the customer order, so in another product part. Okay, continue to the function of this DBNS. We have this transaction support. So with or without of this transaction support, during our practical, later we may have we may find this problem. Okay, we have some transaction here. You can see we continue. We start this procedure, and we have a grading. We try to get some selection, and if this reservation is acceptable, then we continue do the updating for the seat for the flight record and the seat for this return flight, departure flight and return flight. After we do the updating, we insert this to the reservation record. Okay, so if during of any of this transaction here, update or insert, we find some problem, it won't allow us to do the update, or it won't allow us to do the insert, then we need to, on error, okay, if we find any of this error, then we need to roll back. So once we roll back, all these three transactions, update and insert, is roll back to the previous stage. Okay, so this is the use of transaction support for when we have this function of DBNS. So the good point here is, of course, the person in charge, let's say the clerk who in charge to update the record. Of course, a human being always may always have error. So sometimes they may not remember or forget to update some part here. We have a three changing of this record to different table. If any of this part is wrong or forget to do, then it may not be tallied. Okay, so based on this transaction support here, let's say using this procedure or function, actually we go through all this. If any part is fail or have error, then we just roll back, and of course do some printing of this warning to the user who execute this script or function. Okay, so a lot of time this will go through some temporary table, do some changing. If everything is a success, then only save it to the actual table. Okay, so if something goes wrong, then the transaction log may be applied. Then the person in charge to key in this part or to execute this script may need to take care, and may need to report to the manager. Okay, so this one is another good point why we want to have this DBNS. Okay, continue to this part is the system catalog. Okay, I will show this page, then I'll continue mention about this part. Okay, this one is a user accessible system catalog, data dictionary management. Okay, so you can see one of these system catalogs here, the data dictionary. So data dictionary, it mentions about all the behavior or all the transaction or all the record. When we want to execute, it may need to go through this part, checking whether there is any permission. If for, let's say, DDL compilation, when this DDL is run, it needs to check whether this statement can be run by the DBA staff or not, whether they violate any of the rules set inside this system catalog. So if everything is okay, then only it will build the system catalog here. Okay, so you can see we have some dot line here. Let's say DDL, query optimizer, DML, or compiler. So each of these transactions, before it starts, it will actually go through this part, do the checking first. If this one get the permission, then only it do the actual. Let's say for the query optimizer, then it will, after they get the permission, authorize, then only it continue to process the query. Okay, so this one is the first part, why this system catalog is there. The system catalog is a repository of information or metadata describe the data in the database. So when they start, they go through this part, checking where is the database. Okay, where is the database, whether the database is possible to access by the user, okay, cashier user or the application or programmer. They go through and do the checking first. One of the fundamental components of DBNS. So since this one is like a gate, they have this permission. So to check first before it execute. So this one is the basic component of DBNS. Normally, this part will store the name, type, and size of the data items. So if you have some data inside here, when we do the description of the database, it is actually store everything here. So it not even need to come to the database. It will have the description when we define the DDL here. Okay, name of the authorized user and constraint of this data. So they do the checking, see whether this user is actually able to access the table or a particular, let's say last week we already mentioned, when a particular user, let's say for this query, the cashier user, so if they can access to the database, but whether they can do the updating or they can select any of the field or not. Maybe they only can select field A, B, C, but not D, E, F. Okay, so this one is something the checking of this system catalog. Some of the data can be authorized to access, but some no. Okay, data items are accessible by a user and the type of access. So you can access it, but whether you can update or not. Using a usage statistic, this one is the last part, the usage statistic. A lot of this security part also use this one as a guide. If some of the user access to a table or to an object too frequent and out of the common usage, too many times, then the system may give a warning to the DBA after some time. Let's say too many times, let's say more than 10 times a week, compared to the previous usage only 1 time a week. So they may give this DBA a warning. So the behavior of this transaction may not be secure, or this DBA may need to take care of this. Okay, so based on this usage statistic, a lot of this security problem is actually prevent to the checking of this usage. Okay, so continue here. DBMS consult the system catalog. This I already mentioned before performing almost every action. Okay, almost every action. So you can see the dot here is actually go through all this, check whether the authorized user is there or not. If you are not the authorized user, you may not even able to list any of the data, or you may not even able to log in. Okay, so let's say for example, we create for our predicate 1 or 2, when we are before we create one new user, sometimes we're not even able to access this SEPDB1. Okay, so we may need to do some changes first, then only we can authorize to list some table in the new table space. Okay, process this query, and of course the last part here we have checking the this integrity. Okay, so this part to the dot part, then continue seeking this advice of this system catalog, see whether this user is permit to use the permit to run the action on it. Okay, so we not only have this system catalog, we will also have this user catalog, user object, user table, user tab, column, and user view. Okay, so each of these have its own content. We won't go through all. Okay, but during our practical, we will go through this user table, listing who is inside this table. Okay, we have this all user. So when we have this describe all user, you can see the table field here. We have a username, user ID, great. We still have a lot at the back here. Then it tells us how we're going to select. Let's say, but we want to select something from this all user. We can select username, user ID created from the all user table. Then continue to filter out which part that you want to use. So to check whether you have the usage, whether you have the right to access some particular database on it. Okay, next part. Component of this DBNS. Okay, so just now we already have a basic idea of using of this system catalog. So based on each of these item in the DBNS, we can continue seeing here. Okay, so the red color box inside the DBNS is a partition. Okay, each of these processor is actually, or process is actually break and take care by each of the processor. So we have this DML. For the programmer, when it want to do a contact, or when they want to have an action to access the database, they actually go through this DML preprocessor. Then this part, they will just do some changes to the code. Try to change the program to a code that is understand by the database. Then send it to the database management manager. Try to execute, see whether okay or not. Then I'll continue to the next part here. Access the file manager, then I'll continue access the last part, access the database and system catalog. Okay, so you can see when we have this database management system, a lot of this task or action is actually break into smaller parts. Although they can just communicate to each other to seek for help, or before actually sending the request to the file manager, or request the data from the database. Okay, so this one is some of the process they may go through. Okay, so we go through one by one for this part. For the query processor, when the user type some query, so let's say you type this query from this SQL path, it will just pass through to this query processor, see whether your query can be executed or not. Okay, so just now we already mentioned it will just go through this system catalog to check your permission first. Then if everything is okay, then it will communicate to the dictionary manager. This one is the SQL, the system catalog. Everything is okay. It will just pass back to the DML3 processor to change something, or this part may send the program code to the query processor, then only pass it to the database manager. So this one we already mentioned, it may call each other to help based on its own responsibility. So the DML3 processor actually go through this part and continue access the database manager. Okay, so this one is for the query processor pass something to low level to instruct to give an instruction to the database manager to execute some script. Okay, this one is just about it. The DDL, this one we already mentioned the define compiler. Checking this catalog, see whether can or not, then only update this system catalog. Okay, so the responsibility of this database manager, we have this authorization control, see who is able to access, okay, and which part. Command processor, when this script pass in, it will execute. Doing this integrity checking. Query optimizer, so some of the query when it pass in, they actually are quite long, maybe too heavy, and for the database manager, if you're trying to do some optimize, okay. So hey, if too heavy, then the data may be too much, so it may do something to optimize. Okay, some of the database manager even try to help. Okay, try to help. Not all the result will be shown to the user. If it is already over the size of the screen, they may just jump to the end. Unless you give a special instruction, say I want to see all the record, then it will just display. Otherwise, some of the record, it will just it will just not show to the screen. So you may not need to wait too long time in order for the whole result to show up. Okay, so just now we already have this transaction manager. We already mentioned this. Then on the next one here, we have a schedule. Okay, a lot of time for this database management system, we have this schedule. So let's say when month end, we want to have this schedule to do a backup. So we have this backup schedule. We also have this recovery manager if anything goes wrong. Okay, let's say power failure. Some of the transaction is halfway. Okay, some of the transaction is halfway before complete. Then when we have this recover manager, it may help to solve this problem. Put everything roll back and also send a record or send a warning to the user to continue or to restart the transaction. Okay, last one here we have this buffer manager. We all know each of this machine CPU is the RAM management is always there, but if the database is too large, until a certain stage that some of a lot of users log in and do the transaction. Some of the memory may not be enough, and it may need to eliminate, or some of the database which is not really needed may need to put into sleep or escape from the memory. Okay, so this one is some kind of this buffer manager. Okay, so we complete this component of this database manager, and continue to the next part. Here we have this ANSYS fast architecture. Okay, so this one is the shortcut name of the American National Standard Institute Standard Planning and Requirement Committee. Okay, so this not say department, but the institution or committee, they try to design this database. They set the design standard. Then later, when any of these company want to develop their own database management system, they actually follow this standard. So it will help this company to eliminate a lot of this problem during the development of DBNS. And currently, most of the modern commercial DBNS are actually based on this standard. Of course, it will keep changing. If any problems occur or some of the idea cannot meet the current need, then they will suggest to create the new standard. Okay. Okay, so currently we have this three-level architecture. You can see we have this external view level. Based on the end user part of point, they will have a view 1, 2, and even n. So each of these user, when they view this database, they only they only see part of the database, which is relevant to the user. So let's say for the manager who view this database, they may have a lot of this field that they have the authority to check it. But let's say for some of the end user, let's say club, they may not even have some authority to see or even update the field. Okay, so this one is, although it still using the same database, but some of the field or some of the table, some of the user is not actually able to view it. Okay, so this one is based on the external level. And then we have the second part here, the conceptual level. This one is based on the community view of the database. The actual of this table, what this database is actually stored in the database. You can see the picture here. Based on the external view, the user one may see this kind of info. The user 2 may only see staff name, number, name, and the branch number. So although they actually access the same database, but the fields is totally different. Okay, so this one is the external view, and the second is the conceptual level. So the conceptual level just mention about which field, but actually they do not need to bother what is the field size or field type. So the internal level, only on this part, they need to consider, okay, so this one is the field for the staff name is actually integer. Okay, so this part for the internal level, it is how this data is actually stored in the database. Okay, so based on the picture we show, then we can differentiate this three-level architecture when this committee, they try to set the standard. Then later when each of the company, they want to develop their own DBNS, they actually follow this kind of standard, and hopefully they won't have much trouble. Okay, so you can see here, all users should be able to access the same data, but same database, but which part they actually are viewing, they don't know. A user view is email to change made in other view. So this part we say, if anything here we want to do the changes, it won't change the user view. So if we want to change something here, if the DBA want to do some changes to this part, move around, adding more field to the conceptual level for the table here, then the external view, they won't discover that anything actually changed to the table. Okay, last part here is the user should not need to know the physical database storage detail. So whether this table is saved using, let's say, is saved in a pen drive or saved in the hard disk, the physical, how we're going to save this database, the user not need to know over this. Okay, so this one is the objective of this three-level architecture. It mentioned that user only see this view 1, 2, and 3 or n. The user do not need to bother too much about the how or what this data is saved and how this data is saved to the database. Okay, so this is the objective of a three-level architecture. Okay, same thing here. Just now we mentioned about the user, but now we say about the DBA. DBA should be able to change the database storage structure, this part, without affecting the user view. So you can see if I do something here, changes, the user only see this part still the same. Okay. The internal structure of the database should be unaffected by changing the physical aspect of the storage. So this part, if I want to add something inside here, it won't affect. Okay, it won't affect this data is saved to the database. DBA should be able to change the conceptual structure of the database without affecting all the users. So if I change everything here, increase the size of let's say first name, last name, the external viewer won't discover, or the conceptual part, it won't do any effect to this part. Okay, so this one is the objective. Okay, repeat again. The major objective for this three-level architecture is to provide data independence. So just now we already mentioned the changes to all this from user point of view or from a DBA point of view. When they do the changes, they actually do not or will not affect other users. Okay, so we have this thing to come back to this data independence. When do any changes to this part won't affect other parties. Okay, so whether it's in the conceptual schema or the internal schema, it is the same. The logical and this physical data is still independent. Okay, so this one is the logical data independent and the physical data independent. You can see the blue color part here. Additional or removal of the entity attribute. This one, the changes won't affect the view or the external schema or rewrite the application program. So when you do the changes to this part, hopefully these are based on the objective, the application manager or the external view, they do not need to do any changes. Okay, so this one is the logical data independent. For the physical part, you can see if different file. Okay, we have this file organization, storage structure, and device. We use the device as an example. So just now we already mentioned for device, if I want to save this thing to a pen drive, save this thing to hard disk, or I want to put it online, cloud, it actually won't have any effect. If my database management system point to the correct device, then if I do any changes, it won't be affected. So this one is the logical data independent and physical data independent. So when I do any changes to the the blue color part, this part, example, this one is the example. If I want to do any changes to this part, it actually won't affect the whole system. Okay, the last part here, we have this multi-user database management architecture. Okay, we know from the development of this DBNS, actually from long time ago, if I'm not mistaken, is more than 60 years of development, and we have this architecture. It keeps do changes. If this one is not good, based on different objectives from time to time, based on the company requirement, they actually do some changes. Okay, so previously, so maybe 20 years ago or 30 years ago, actually that time won't have so many computer A lot of this transaction is actually record to bookkeeping. They need to write every transaction to the book. If anything goes wrong, they may need to rub it, or they may need to use another page. Say the previous one is wrong, then they need to use another page to record the new one. So they may need to write a lot. Okay, so start from I think 20 to 30 years ago, they come up with some of this architecture. They try, then continue do the amendment, changes, improvement. Then only we have this today's Oracle or MySQL or Access for us to use, and without actually doing the repeating of rewrite everything if anything goes wrong. Okay, so the common architecture here that the first one is previously used is the tally processing. Okay, so we can see something here. One computer is actually one computer with a single CPU and a number of terminals. Okay, when we previously when we see this keyword terminal, it actually means the computer that without okay, I can say this, a computer that actually without calculation power or processing power. It actually used as a remote control to the server. Okay, so this part is one example. Tally processing, one computer with a single CPU and a number of terminal. So the processing are performed within the same physical computer. So each of these terminal connect to the to this CPU, and everything is just work here. This part is just at like an interface. Okay, so let's say if you use a remote control service from your window to another window, you can see that this computer actually doing nothing. The processing power is extremely low. maybe some network is there, but the transaction or the processing is actually complete everything in this CPU. Okay, user terminal are typically dumb, actually doing nothing, okay, doing nothing, incapable of functioning on their own. So this part only a remote access to the server and a cable to the center computer. So it's to network. They just connect to this CPU, and this CPU doing all the work. Okay, so this one is the use of this tele-processing. Okay, so last time, of course, the CPU is very expensive, and of course, OS is not so complete yet. If you have this tele-processing, then a lot of different users actually can work together to finish a task. Of course, this part, the CPU must be powerful enough to do all the tasks. Okay, so this one is the first example. Second example here, we have this file server architecture. Okay, so this now is the tele-processing architecture. Now we have this file server architecture. You can see we have a lot of this workstation here connect to a LAN, and it actually requests something from the file server, and this file server they built this database here. Okay, so okay, the database management and application run on each of this workstation. They request this file. Okay, they request this file. Then each of this workstation, they actually have this DBNS. Everything done. When they close, the file is sent back to the file server. Okay, so this one is actually when they start, they get the file, then the files return to the workstation. They continue doing their work here until everything is okay, then they send back to the file server. Okay, so this one is the file server architecture. Okay, so this one we seldom use, but if you work in our lab, it is possible that we run this. We want to share some files. So previously we didn't have this online. Even in our lab, we won't have online. So we won't have a GC in our lab as well. So what we actually do is when we want to share, let's say this PowerPoint, or if we want to share the practical question, we actually share it to our lab network. Okay, so this one is all others computer that you use actually connect to the same LAN, and this lecturer or computer is actually sharing the file of this lecture note or the PowerPoint, the practical question, or even the answer. Okay, share it to using this file server. So if everyone is actually access to the file server at the same time, then it may not, okay, it may not able to fulfill the request. Okay, so this one is one question. If you use our lab computer, then you should know this. Okay, the DBNS and application run on each workstation. Until everything is finished, then they save the work back to the file server. Okay, the disadvantage of this is significant network traffic. So just now I already mentioned. Last time, network only have a maximum of 10 meg. If the file is too big, then when you want to save something to your workstation, it may take a little bit longer time. I remember last time when we sharing this MP3 to our friends, one pen drive 128 megabyte of song MP3. We actually share this I think more than 10 minutes in order to share it to others friends. Okay, so this one, the network speed is not, the LAN speed is not fast enough in order to process or to transfer all these files. Okay, so this one is the significant network traffic. So if your LAN or your switch is not fast enough to transfer all this to the destination from the source, then it may take long time. Okay, copy of this DBNS on each workstation. So the file copy to the workstation, then they continue working on it. Only after they finish, they send it back. Okay, so by this, it actually have a lot of this problem, the problem of concurrency, the problem of recovery. Okay, of course, for concurrency, last week we already mentioned, and later we may ask some students. Previously, I already assigned some students to explain it again. Okay, for the concurrency. So if any of this happen, then it may be a problem. So this is the problem of this multiple DBNS access to the same file. It will have the same problem. Okay, so we may need to do some take some control to this part. Okay, and I'll continue. We have this traditional two-tier client server. Okay, for the tier one is the client part. You actually manage this user interface and run the application. So you can see this one is a remote desktop, like a remote desktop. It actually remote to the database server. Of course, the interface is still there. Then only you continue do your processing. So if you run, if you develop this VB Visual Basic program before, it actually doing this. Okay, so you already have the interface, and you act like actually removing to the database server. When you change the record or when you select something, it actually directly connect to the database server. Okay, so this one is the first tier client. The second tier here, we have this database server, which is directly connect to the database. Then it acts as a communication tool between the first tier to the database. Okay, so the server-side validation, it do the checking when the user or the client actually access to the database. They do the validation first and see whether they actually can access the database. Okay, so this part we won't repeat again. Previously, the database management system already mentioned. Okay, so we can skip this part. We just mentioned the differential between this first two-tier and three-tier. Okay, so summary of this client server function here, we have the function of this part. For the client part, just now we already mentioned the client part work mostly the interface and the logic processing. So this part we have a manage user interface, accept and check syntax of the user input. If you develop some of this web page, if you attend this web page design class before, I think this part you should know. Accept this check, accept and check syntax of user input. When we develop this HTML, we also do the same thing as well, checking whether the user input is correct or not. Okay, so processing this application logic, we try during this web page, we also can do some checking whether the user input is correct or not. So let's say number is actually from 1 to 10. If the user input is more than this, then it may be a problem. Okay, so this one is processing the application logic. Generate this database request. If everything is okay, then generate this database request and transfer it to the server. And if the server go through the whole process, everything is okay, pass the result back, then this client part will be responsible to display the result to the user. Okay, so for the server side, actually, when the client connect or pass some tasks to this server, they actually accept the process and do the checking, request from the client, then check this authorization, ensure the data, the input, the integrity is always there. Okay, so the constraint is checked first before they actually process it. Okay, perform query update processing and transmit response to the client. So this one is passed back to the client. Then of course continue to do the maintenance of this system catalog, provide concurrent database access, provide recovery control. Okay, so this one is work behind. Okay, working in the background. Okay, so this one is the summary of our client server function. We have continued to the second part here, comparing these two tier and three tiers architecture. So previously we mentioned the first tier of this client actually have this user interface and continue the main business logic and processing. So this part, the task of this client actually quite a lot compared to the second one, compared to the three tier. So after you do the processing, only it requests from the server. So this one is what we call set client. So the process or the task need run in this client is quite a lot. So that's why you say require considerable resources, means that the RAM, the CPU power is actually the need of this RAM and processing power of this client is actually quite a lot. Okay, so significance client side administration overhead. So this part, some of the old computer may run extremely slow. So if the return from the server is quite large, then it may hang. Okay, so this one is previously we have this two tiers client server. Okay, so compared to the third one, we have this three layer. By 1995, this committee, they proposed the new three layer, and each of these potentially run on a different platform. So you can see we have the client part, the first tier, the client part only have this user interface. So you can see the main business and the data processing, the logical part, they just remove from the client, the first tier. Okay, so it will eliminate a lot of this computer actually cannot do this task, and they may not be able to connect to this application. Okay, so advantage of this three tiers client server, just now we already mentioned. For the two tier is too fat. Okay, it need a lot of this CPU power in the and RAM resources in this client part. So for the third three tier, this one is thin client. It require less expensive hardware. So later you may see some of this, even a tab can actually complete this task. So previously, if we have a notebook or tab or even now a smartphone, when we connect to the application or the web server, it actually can complete the whole thing, okay, without actually increase the RAM or even the processor, because everything is done through the second tier, the application server. Okay, so application are maintained centralized. So the application is stay here. The server will take the control of all this, try to do the business logic and do the data processing inside here. After they get everything processed, just pass back the result. So the client part only act as a user interface. Okay, easy to modify or replace a one tier without affecting the other. So you can see anything problem, we say easy lah, but easy it doesn't mean that it won't cost anything. So any of this part is wrong, they just replace it with the new hardware, so it should be okay. Okay, so easy to modify without actually affecting the whole process. Okay, separating, you can see if based on our previous example here. Okay, based on our previous example here, the client, the first tier, the client side have this business and data processing. So it means all the computer which is the client, it needs to install this program. Okay, so whereas the three tier, this part, the client only have this user interface. Okay, so it like what we have like what we have your browser, when we run, okay, when we run using tab or laptop, we only need a browser. So if your browser is okay, means that you can just connect to an application without any problem. Okay, so this one is this part. Easy to modify or replace one tier without affecting the other. Separating this business logic from the database function make it easier to implement the load balance. So you can see this part, later we have another picture for this. Okay, this server will only in charge for the application. This server will only in charge for the database server. So if the loading is too much, means that too many requests of a service, then actually they can break it into two. And of course, the server will have a more capability of serving more client at the same time. Okay, so means double. Previously, let's say one server combined application and the database can serve 100 of a client. Now can be more than 200 because it won't be at the same time. It won't be at the same time. So it will be much more, the load balance can be more there. Okay, later we have another picture for this part. That make quietly natural to the web development. So the keyword here we have this web development. Let's say this part. The application and this web server is there. So during our current situation, a lot of this computer or tab is actually connect to the application to web server rather than an individual application. So even, okay, let's say even for the tab or for your smartphone, when you run an application, it actually seamless checking, linking to the web server or the application server. Okay, so this one is seamlessly. Okay, so this one is the picture of a two tiers client and server. You can see there is no local database inside here for the tab or for your smartphone. For some of our others computer for the client here, it may have some others processing. So if get all the info already, sometimes they may need to do some printing or some update to the customer or receipt. Okay, so they may have their own processing, but it is possible that not even our database in the tab or smartphone. Okay, currently a lot of this current situation is using a handphone or even tab to complete all the tasks now, rather than individual need to have one laptop or computer. Okay, so this one is a current three tiers client server. This one is current one, modern database management. Okay, so we have a 5-minute break. Come back around 10. No, 15. Before you go, put a +1. Okay, so this time we already mentioned we have another picture of this two-tier or n-tier of this client-server architecture. Previously, we already mentioned this web server and this application server is in the same tier. Okay, so in order to make this n tier, or in order to take care of this scalability, if the processing of or the number of a client, the first tier is too much, then it is possible that we break this server again to a different tier, or break this web server to another part. So any of this connection, they will actually connect to this web server first. Then the web server will take care of all this interface. Then the application part, the application server will take care of the logic and the processing. And the database server actually only maintaining or checking of this database. Okay, so by breaking all these specific tasks to different server or different tier, it means the scalability of this overall architecture will be much more stable. Okay, so of course we only have currently we are only up to 4 tiers here. So application of this part is actually host API to expose the business logic and a business process for the use of other applications. So if previously we didn't have this thing called API, but if you run or you develop this Visual Basic before, you actually come to this image of this API. The program that actually communicate between two server or two computer. So it actually didn't doing anything but only only communication. So something you pass it to me, I pass it to the correct person who in charge of this. So you pass me a message, I pass the message to another server. So okay, you in charge for this. So you can see we have one transaction processing monitor here. So through use of this API or use of some of others this transaction processing monitor, we have the idea of get all the service call, pass it to this transaction processing monitor, and see which of the service or which of the server is actually free to entertain the request. Then I just continue send it to individual of the server. Okay, so this one is one idea. So form of the middle tier of the 3-tier architecture. So we have a 3-tier, and we also have this transaction processing monitor. See which application is actually see which application server is actually free to entertain. So we can have more than one application server, and this transaction processing just pass the task to individual application server. So TP monitor is a program that controls data transfer between client and server in order to provide the consistency environment, particular on the for the online transaction processing. Okay, so for this part, you can see when the number of a client increase at the same time. Just now we say is sometime here, if if previously this server can entertain 100 client at the same time, now it can be more than that, because it already divide the task to different tier. Okay, so web server will be able to entertain 200 example, 200 this incoming request at the same time. Then the application server will just try to process as fast as possible, pass back the result. So the number when we break the tier into break the server into more when we increase the server number, we can increase the number of clients that we want to serve. Okay, so the idea here is that if the service call incoming too fast, too much at the same time, then we can use this thing called transaction processing or monitor. Okay, very common that during a certain period, so let's say for the whole year, this let's say Lazada or Shopee, the server that try to serve a customer, the processing is only, let's say, 10 to 20% for the normal time. But yeah, it is possible that during this let's say big sales, 11th of November or 12th of December or New Year, let's say 31st, the 1st of January or 25th of December, during this few days, the transaction will be, or the processing of this CPU may be nearly 100. So it is possible that the server may be down if it's too hot. The processing is too much. Some of the customer may not even able to log in and to choose their product. Okay, so by using this transaction or processing or monitor, they can actually increase the number of this application server and try to give more service to individual. Okay, so this one is the idea, and hopefully actually can do it in the real world. Actually, if the computer is cheap, if the server is cheap now, actually a lot of this company actually can buy more application server or this web server and just try to serve all the service, all the incoming service at the same time. Okay, so this one is their idea. Okay, then the last part here for the transaction processing or monitor, of course, we will for this one we will continue to talk more about this during week 11, and you can see during this big sales for Taobao last year, 2021, the number of this sales is 900 million within China, and 290,000 overall in the world. Okay, so combined of this is already more than billion. Okay, the amount of sales is US dollar 84 billion. Okay, 84 billion. So the amount is quite large, but of course during this 11 November, the sales previously is only one day, but this time is the whole week. But of course the only a big day sales is still fall on 11th of November. Okay, so this one is some challenge to the computer that provide this service to Taobao. Okay, so if this one will continue mention during our week 11 chapter, I think chapter 8 or 9. Okay, so the last part here for this DBNS is this distributed architecture. So a distributed database is a logically interrelated collection. So you can see we have this, let's say site 1, site 2, site 3, site 4. They actually connect to this network, internet or local area network. It seldom be a local area network. Normally it's to internet. So it is a collection of shared data and physically distribute over the computer network. So the reason why we want to have this distributed DBNS is because the connection may be, the location may be too far, and the department to control each of this database maybe in a different place. Okay, distributed DBNS permit the management of a distributed database and make the distribution transparent to the user. So the user who log into this network or to use this net service, they not even know which site they actually go to. Okay, so this one is a very good sample of this Google. Google actually adopt this distributed DBNS. When you are actually log into YouTube, you may not access to the US site. Sometimes you may access to the Singapore web server. Okay, so everything is still the same. You won't see whether there is any different or not unless you go to ping the IP address. Then only you discover, oh, I actually connect to, let's say, Europe website or US website or even Singapore, the Southeast Asia, etc. Okay, so this one is by providing the same service using different sites, but the database is actually the same thing. Okay, so this one is the distributed DBNS. Normally, why they want to do it? Because the place to transfer this data from one part to another part may be too far away. So let's say if for this YouTube, the movie or the song transfer from let's say deliver or transmit from US to Malaysia, it takes too long. So Google try to put a lot of these different server in a different place in a different country. So if your country have this Google service, then of course when you connect to this server, it will be much more faster. Okay, so for Southeast Asia, we actually connect to this Singapore site. Okay, so this one is some introduction to database system. Okay, so if I'm not mistaken, last week I asked a student to do something. Who is it? Wai Heng, right? Is Wai Heng here? It's okay. Just try. So you want to explain? So I just stop my sharing. Wai Heng, you want to share your screen and talk something about what is that? Wai Heng. Next one is Chao Jiang. Alama, I thought I can let you finish your part, then we can stop. But now it's too earlier. Is Chao Jiang here? Then never mind. Is Chao Jiang here? 超酱单超酱。Wai Heng, can you prepare now because we still have 30 minutes. I thought I can let you finish your part, then we can end our class and enjoy our Chinese New Year. If no, then I have to start chapter 3. Then maybe too burdened to me. Chao Jiang, there is no answer from Chao Jiang. Let me try. Yes. It's okay. We learn from mistakes. Okay, you can start. You want to share your screen? It's okay lah. It's okay. Can someone call Chao Jiang? See whether he want to join in. Chao Jiang, Dan Chao Jiang. Wei Heng, you can start sharing your screen and continue. Wei Piao, okay. Chao Jiang just join in. It's okay, Wei Piao, can you help? Can you put a +1 now? So at least okay. Oh, Chao Jiang, you just join in and you put a +1 without telling me. Chao Jiang just now. Okay, Chao Jiang just left 4 + 4. Okay, Chao Jiang, you need to prepare. I think last week I asked you to do something, creating something quite similar to grid table, right? Chao Jiang, answer please. You outside driving, you go back to your hometown, or you come back? No, it won't be possible come back, right? It's okay. So Chao Jiang, I will reserve this your part back to hometown. So will you join the class Thursday? No, mate. I mean that the coming Thursday. So if you are driving now, yes, okay. Then we reserve your chance to coming Thursday. Although we won't have much time now. Okay lah, you concentrate driving. All those I asked you, then you don't want to join lah. Okay. So never mind, I will reserve this to next Monday. Next Monday. Okay, then we wait for Wei Heng. Okay, so for this concurrency, always a big topic or the common exam question during your final, or sometimes it will come out from for the midterm. So that's why we spend some time, let Wei Heng finish this part. Then we can stop and enjoy our Chinese New Year.
Hi, sir.
Hi, okay. So everyone can hear? Okay.
So, as you know, so the condition is in the website, the product X is only one unique stock, and at 3 p.m., two customers A and B get added the same product, at the same time, just 3 p.m., 3 p.m., they done the payment and done the purchase at the same time. So the product X need to minus one, but if both of them done at the same time, the remaining stock is not enough for the database to get. Is this correct?
So fast? Yes, of course, it is. Yeah, it's correct actually. But I actually haven't really go through, but I know the last part mentioned is the product as a remaining stock is wrong, is not correct. I just written this part. I still adjusting my speakers out. Then you finish already. Okay, so student, this one is some example. Thank you, Wei Heng. So Wei Heng, do you want to try how to solve this problem? Okay.
So the one who faster in nanosecond or millisecond is just take the product. The other one will not able to confirm the order.
Okay. So this millisecond taking of the chance is quite yeah. Okay, thank you. So at least we know the problem, and we suggest some answer or solution to the concurrency problem to prevent this the wrong result is actually saved or record to the database. Okay, so done, and I think 20 minutes you can. Okay, so if is it okay we just end here today? Yes. Yeah, well, after seeing okay, so others do know. Yes or no? No. Yes. Okay. So I just mentioned Thursday we will have practical. I will try to upload this task as early as I can. I haven't start preparing yet, so sorry for that. So early morning you may need to spend some time, although it's still during a Chinese New Year holiday. Okay, so students, we end here today, and wish all students Happy New Year, and enjoy your Chinese New Year. Enjoy your food, but don't eat too much. Otherwise, it'll be a little bit sad. Okay, so we end here, and thank you very much, and see you again in the coming Thursday. Okay, bye-bye.